form. So a form such as, well, maybe a polynomial plus something of the form some polynomial over another polynomial, where this polynomial is maybe a linear term, and this will be just a term that has degree less, meaning a constant, over some linear term, or maybe a constant over the linear term squared, or again, a constant over this linear term, plus a linear term over quadratic, plus maybe, so such as I could write something, say 8x squared plus 9x plus 2 over x plus 1 squared as some constant over x, because look, there's an x here, 2 over x, plus some constant over x plus 1, because there's an x plus 1 here, so this is over x plus 1, plus some constant over x plus 1 squared, because you have a squared. So you have to include both x plus 1 and x plus 1 squared. So minus 1 over x plus 1 squared. So if I can somehow a fraction, a rational function in this form, we say that that's a partial fraction decomposition. So let me be a little bit more specific. Let P of x and Q of x be polynomials with real coefficients, and suppose that the degree of P is less than the degree of Q, and suppose that Q looks like a1x plus b1 to the n1, a2x plus b2x plus b2 to the n2, dot, 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 times maybe some other stuff. C1x squared plus d1x plus e1 to the m1 plus c2x squared plus d2x plus e2 to the m2, dot, 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 things of all of that form. Then P of x over Q of x is equal to a constant, a1 over a1x plus b1 plus a constant a2 over a1x plus b1x plus b1 squared, dot, 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 all things of that form, plus a sub n1 plus, I should have called it something different. Let's call it n d n1. Okay. A sub 1x plus b sub 1 n1 plus a whole bunch of other, plus things type, plus things of this type, b1x plus c1 over c1x squared. That's a capital C, this is a lowercase c. C1x squared plus d1x plus e1, plus a whole bunch of things of that type. Oh, who knows what I should call that? Plus things of this type. This can't be subgroup. Maybe with primes or something. They're different things. Okay. So a partial fraction decomposition. Oh, notice that if the degree of P is greater than the degree of Q, I would just add an additional polynomial here. That would be the only difference. Okay, so partial fraction decomposition. Let F, G be polynomials with coefficients in some fraction, in some field. And suppose that neither f nor g is equal to the zero polynomial. Let p sub I be a polynomial with coefficients that are in the same field. And let it be an irreducible polynomial where it's actually the it's the factorization of your denominator. So where g of x is equal to the product I equal 1 to k of p sub I to the power n sub I for some integers, whole numbers n sub I. Then there are unique polynomials b a sub ij with the degree of a sub ij being less than the degree of pi, such that f over g is equal to this polynomial b plus the sum I equaling 1 to k, the sum j equaling 1 to n sub I of a sub ij over b over p sub I to the j power. If the degree of f is less than the degree of g, then b is equal to 0. Okay, so let's actually try to do some examples. Decompose each fraction into partial fractions. So I have here problem number 6. 5x plus 21 over x times x plus 7. So I have that 5x plus 21 over x plus 7. So notice that I have written the denominator here as a product of factors, irreducible factors. Therefore, there must be coefficients a and b such that this occurs. Let me multiply both sides of my equation by the denominator. So then you get 5x plus 21 is equal to a times x plus 7 plus b times x. One way of determining the coefficients, the numbers a and b, is either to equate coefficients or to find some values, plug them in, and try to solve for a and b using those particular nice values. So let's do this. So in this case, let x equal 0. And let's figure out what happens. Why x equals 0? Because you set each of these factors equal to 0 and solve for x. So x equaling 0 then gives me 5 times 0 plus 21 equals 0 plus 7 is 7a. And so from that, I get that a is equal to 3. Now let's make this 0. Notice that making this 0 made my life easy. Making this 0 will also make my life easy. So let a equal -7. Let x equal -7. So I have 5 times -7 plus 21 is equal to, well, -7 plus 7 is 0. So that's 0 equals -7b. And so 21 minus 35 -14 equals -7b. Well, divide both sides of my equation by -7, so b is equal to 2. Therefore, my partial fraction decomposition is as follows. 5x plus 21 over x plus 7 is equal to a over x plus b over x plus 7. And that is your answer. This technique will become extremely important in later classes. This is a very important technique. Problem 28. And so I have, first, let me factor. So notice that in this case, my denominator hasn't been factored yet. So let me try to factor this. Luckily, it's very easy to factor. Factor out an x. What remains is x squared plus 4x plus 4, but that is just x plus 2 quantity squared. So I have that 3x squared plus 13x plus 20 over x cubed plus 4x squared plus 4x. This is equal to 3x squared plus 13x plus 20 over x plus 2 squared. Okay, so let's do this. I have 3x squared plus 13x plus 20 over x plus 2 squared must equal a over x, because I've got an x here, must equal b over x plus 2. But I have an x plus 2 squared, so I have to have another constant, c over x plus 2 squared. Okay. And so let's multiply both sides of my equation by x plus 2 squared. So from that, I get 3x squared plus 13x plus 20 is equal to a x plus 2 squared plus b, one of the x plus 2's cancels, so that's bx x plus 2 plus cx, the x plus 2's cancel. I can either expand this out and equate coefficients, or do the following. Let's try to make some things 0, so that x equals 0. If you let x equal 0, you have 20 is equal to 2 squared for a plus a whole bunch of zeros. So a is equal to 5. That makes my life good. Let x equal -2. And so I get 3 -2 squared plus 13 -2 plus 20 is equal to, well, 0 squared, that's 0. 0 times anything is 0, minus 2 times c. And so I get 12 minus 26 plus 20. So I get 32 minus 32 minus 26 is 6, is equal to negative 2c. And so c in this case is negative 3. Okay, let's do another page here. Okay, good. I'm moving now. And so let x equal 0. X equaling 0 will help me. Oh, I did 0. I already did 0. Okay, so lastly, so I have two numbers. Lastly, let me take the derivation. Oh, you can't take the derivation because you don't know how to take derivations. Let me just plug in another number. Let me just plug in 1. So let's just let x equal 1. It's not the best number, but it will work. 1 isn't such a horrible number. Let me cheat by figuring out what this is. Okay, so copy. Okay, so let's plug in 1. So I get 3 plus 13, 16 plus 20, 36 is equal to 1 plus 2 is 3 squared is 9a plus 3 times 1 times b is 3b plus c. Okay, good. Now, let's simplify this. So I know that a is 5. I know that c is negative 3. So 36 is equal to 42 plus 3b. Subtract 42 from both sides of my equation. And so 3b equals negative 6 divided by 3. So b is negative 2. Therefore, I have, I'm going to cheat, I have this. Oh, no, actually, I want this guy here. I know that this my original equation, therefore, is equal to a over x plus b over x plus 2 plus c over x plus 2 squared. And that is my partial fraction decomposition. Let me do problem number 38. And so, these are irreducible. And so I have that x cubed. And x cubed is less than x to the fourth. So this is just going to be a fraction. I don't have to divide anything. So I have x cubed plus 3x squared plus 2x plus 4 over x squared plus 1 times x squared plus x plus 2 is equal to, well, this is a quadratic, so it has to equal ax plus b over x squared plus 1. And the next one is quadratic also. And these are irreducible, so you can't reduce these. So cx plus d over x squared plus x plus 2. Okay, so let me multiply by x squared plus 1 and x squared plus x plus 2. Okay, so if I do that, I get x cubed plus 3x squared plus 2x plus 4 is equal to x squared plus 1's cancel, ax plus b x squared plus x plus 2 plus cx plus d x squared plus 1, since the x squared plus x plus 2's cancel. So let's try to figure out what each of these are. X squared plus 1 is 0 at I and negative I. So let's let x equal I. See what happens there. So, ooh. So this is I cubed is negative I squared is negative 1, plus 2I plus 4 equals, plug in I, so this is A times I plus B. I squared is negative 1 plus I plus 2. And then I squared plus 1 is 0, so that goes to 0. So hopefully I'll get two numbers here. And so I get 4 minus 3 is 1. 2I minus I is I. Is equal to A plus I, AI plus B, sorry, times 1 plus I. 2 minus 1 is just 1. Let me multiply this out. So I get B times 1 is B. AI times I is AI squared, which is a negative A, plus AI times 1 is AI. B times I is BI. So from this, I get that the real and imaginary parts must be equal. So I get that B minus A is 1, and B plus A is 1. So if I add these, I get that 2B is equal to 1, is equal to 2. And so B is equal to 1. But if B is equal to 1, let's go in the second equation here. I get A equals 0. Okay, so A is 0 and B is 1. That's good. That simplified life quite a bit. Let's plug in, let's say 0. That'll give me something for that. That'll give me D. So if I plug in 0 here, I bet you the minus I gives me nothing because that'll give me nothing because that doesn't involve the C and D. And I got A and B. Okay. So let me plug in 0. So let x equals 0. Okay, so I get 4 is equal to B times 2 plus D times 1. Okay, and I got B was equal to 1. Okay, so 4 is equal to 2 plus D. So D is equal to 2. Equals 2 plus D, so D is equal to 2. Okay, now you could let X equal anything, maybe a 1 is okay. So let X equal 1. So let X equal 1. And so I get 1 plus, that's 4, 8, 10 is equal to A plus B times 1, 2, 4. So that's 4 times this. Oh, raised hand. Yes. Professor. Okay. Oh. Let's see if it scrolls down anymore. They just raised hand, but nothing else. Okay. A 1 plus, that's 4, and that's a 1 plus 1 is 2. C plus D. I have A is 0 and B is 1. So that's equal just to A plus B is just 1. And 2C plus 2 times D, 2 times 2 is 4. So I have 10 is equal to 8 plus 2C. So 2C is equal to 2. So C is equal to 1. So I now have my answer. Let me get rid of this guy. So my answer is, I have to look up to the very top because I've forgotten what the question is. So it's this guy. So copy. So finally, I have the partial fraction decomposition. So I have x cubed plus 3x squared plus 2x plus 4 x squared plus 1 x squared plus x plus 2 is equal to A was 1, B was 0. I'm sorry, A was 0, B was 1. So A was, and then C is 1, and D is 2 over x squared plus x plus 2. And that is my partial fraction decomposition. And so I have